Hello everyone. Let us see the next example of this chapter. Solve the integral equation. This is 19th example. Solve the integral equation. Integration 0 to infinity f of theta cos alpha theta d theta. Theta is the variable here. Its value is 1 minus alpha. It is a function, one function whose value is 1 minus alpha when alpha is between 0 to 1, and it is 0 when alpha greater than 1. Hence evaluate this integration 0 to infinity sin square t upon t square dt. Okay, our first question is where to solve this integral equation. Why this is called integral equation? Because integration is there. Okay, and solving the integral equation means to find out the unknown function here. What is the function here? F of theta is the function. Okay, rest of the terms are given functions. This is also one function. Alpha is a variable here in this function, and here cos alpha is another function, but f of theta is the unknown function here. And finding out the unknown variables in any equations means the solution of any equations, but this is the integral equation. That's why solving the integral equation means to find out unknown function present in the equation. Okay, that means from this given information we have to find out f of theta using Fourier transform formulas and different properties. Okay, and whatever the answer we are getting of this question, using that only we have to evaluate this integration. Okay, let us see the first question of this. We have to solving the integral equation. We have just discussed this. Means finding value of f of theta, that is f of x. Let us, for our convenience, we are going to change the variables here. This is not mandatory. You can solve it as it is, but replacing the variable in our usual notation makes that question seems very easy. Okay, that's why here we are going to convert some variables, like for example, for convenience, replace theta here. Theta is equal to x. Okay, and alpha is equal to yes here. Alpha is equal to yes, because in our usual notations instead of alpha, this is one function. Okay, yes is there in Fourier transform variable, and f of x is our usual notation for function, any function. That is the only reason we are going to convert these variables. Theta is equal to x and alpha is equal to s. What we get from here? Integration 0 to infinity f of x cos sx, alpha is for s, theta is for x, cos sx dx is equal to 1 minus s is there everywhere, 0 to less than s less than 1, and 0 it is s for s greater than 1. Now this comes to in our usual notation. Now we have to understand how to find out the way of this answer. We know if you observe this, we are going to find fx from this equation, and you observe this integration. This integration is the Fourier cosine transform formula, right? Here we know the Fourier cosine transform formula of any function fx. That's why we are replacing this theta by x here is given by, this is Fourier transform cosine transform formula. Okay, if you observe this integration with this, these two integrations are equal. That's why this integration is equal. That's why this is called the Fourier cosine transform. This is given thing to us. This is a Fourier cosine transform of the function fx here. What is the Fourier cosine transform of f this function? This is the answer. Okay, this is equal to this. Now we know two formulas. Fourier cosine transform is there. Here we have total 6 formulas. Okay, if you observe this, suppose we are getting this, we are now this FCS is the Fourier cosine transform, and if you replace this by this here, okay, what we get? This formula. This is called inverse Fourier cosine transform. Inverse Fourier cosine transform is nothing but the formula to get this function. If you have this here, okay, that's why using this logic, this is our Fourier cosine transform, and if you find out fx, then ultimately we have to use inverse Fourier cosine transform. Okay, therefore to get fx we need to use inverse Fourier cosine transform. That is the formula fx is equal to 2 upon pi integration 0 to infinity fcs cos sx ds. What is the variable here? The integration is with respect to that variable. Remember that everywhere. Okay, that's why now we already have fcs. What is this? Fcs is equal to this, and this is equal to this. That means fcs is this formula or this function. That's why I put fcs value here. That's why, and fc is given in the interval format. That's why this integration also split into two integrations. That's why the integration becomes fx is equal to 2 upon pi integration split into two. First one is 0 to 1 fcs cos sx dx plus 1 to infinity fcs cos sx dx. I put the values of fcs here. That is a function in s, which is given in the example itself. 0 to 1 fcs value is 1 minus s. That's why we are replacing this alpha by s to get our usual notation. Okay, and in 1 to infinity fcs value is 0. That's why ultimately the integration value becomes 0. Now we have to solve this integration by this very simple integration by parts rule. U into v, this is arithmetic. Integration is with respect to s. This is trigonometry. That's why by Liet rule, this is u, this is v. U into, put the brackets, proper brackets everywhere. U into integration of cos is sin sx upon derivative of angle with respect to s is x. Okay, don't forget to keep in mind that which variable is that with respect to in that integration. Now second term of by parts rule is minus this term's derivative here. Derivative with respect to obviously s is minus 1. Okay, 1 is a constant, derivative is 0, into integration of this total term where x is constant, keep that as it is, and integration of sin sx with respect to s is minus cos sx upon sx derivative is x divided by that is x into x. Already x is there, multiply with that x becomes x square. Okay, bracket complete. Next term will be plus, so minus 1's derivative is 0. Once you get constant here, the series ends at that term only. Okay, by in by parts rule. So curly bracket complete and this square bracket complete. Limits are 0 to 1. Now see, if you put upper limit 1 here, we get 1 minus 1 0, and only this terms remains for upper limit. Put 1 in yes, we get minus 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 3 times minus cos 1x upon x square. We are going to put limits in yes. Okay, remember x is a constant regarding this integration. Now lower limit, if you put 0 in yes, here sin 0 becomes 0, and this is the only this term remains at for the lower limit. Minus minus minus, again 1 time minus cos 0 is 1. We know cos 0 is 1 upon x square. Okay, minus minus becomes plus. Take first denominators are same, that's why take first positive number, that is 1 minus cos x upon x square. Okay, now this is our first answer. We have solved the given integral equation by finding out the fx value. Now our original variable is theta, that's why replace everywhere x by theta. We get f of theta is equal to 2 upon pi 1 minus cos theta upon theta square will be the first answer of this question, main question. Okay, now once we get f of theta, to evaluate, already we know whenever there is a hence part in the Fourier transform examples, what we do to find out the next integration, we use the inverse of that transform. Already we are getting fx here by using inverse Fourier cosine transform. That's why to find out the integration in the example, we are going to use inverse process of inverse Fourier cosine transform, that is a normal Fourier cosine transform. Okay, that's why we know to evaluate the integration we use Fourier cosine transform. That's why FCS is equal, this is a formula for Fourier cosine transform, integration 0 to infinity fx cos sx dx. Already these are the normal notations, that's why fx we are going to use this, not this, because this is in our uh, uh, examples variables. That's why I put this fx formula function here. We get, ultimately take 2 upon pi common constant outside the integration 0 to infinity, this term as it is here, cos sx dx. Okay, now see, we are not going to evaluate this because our main motive is to find out this integration. If you observe this integration and this integration, you will get here denominator contains t square, t is a dummy variable, we can replace it by x. Here also denominator contains x square. Just we need to cancel this cos sx, that means here we want 1, and here 1 minus cos sx, instead of that we get either sine square t, and we know one formula. What is that? Sine square x formula. What is that? 1 minus cos 2x divided by 2. We are going to use this mathematical formula to find out this integration, or we are going to replace this formula here. Okay, let us see. Now from equation number 1, what is our equation number 1? Our original equation, this or this. Okay, from this equation number 1, FCS is equal to this, FCS is equal to this equal to is this. That's why FCS is equal to, this is our above equation 2 upon pi, this term as it is equal to this term. Okay, these are all equal. Okay, once we get this, now here we have to just replace the formulas. Now take we know here sine square x is equal to 1 minus cos 2x upon 2. We want 1 minus cos x only, that's why 1 minus cos 2x, take 2 on that side, we get 2 sine square x. Now make here angle half both side, we get 1 minus cos x is equal to 2 sine square half angle x by 2. Okay, okay, now put this formula here in this above equation, we get FCS. You don't need to write this at this step, is equal to 2 upon pi, this becomes 2 sine square x by 2, rest of the terms as it is, equal to this also as it is. Okay, now take this 2 outside, we get 4 upon pi sine square x by 2 upon this total term as it is, is equal to, now you can skip this FCS here because we want this integration, is equal to this as it is. Okay, now if you observe this integration, first of all we want only sine square t upon t square. Here is sine square angle, we can replace it afterwards, but we don't want this. That means what is the variable here? X. And what is the alphabet or variable apart from x which is present in this integration is yes. That's why on RHS side also function is given in the interval form where s is value, s value lies between 0 to 1 and 1 to infinity. Okay, that's why we are going to put the value of s apart from this variable x such that this becomes 1, and we know for what value of what angle cos becomes 1, that is 0. Okay, cos 0 is 1, that's why we are going to put s is equal to 0 on the both side of the equation in the next step. That's why put s is equal to 0 in above equation. What in the both side, obviously we get 4 upon pi, integration becomes sine square x by 2 upon x square dx, cos 0 becomes 1. And on RHS side, in which interval 0 lies? In above interval. That's why put s is equal to 0 in this interval, we get 1 minus 0, that is 1. That's why integration RHS side becomes 1. Now take 4 upon pi on that side, we get this integration is equal to pi by 4. Okay, now we get this integration but we want only single angle here. That's why ultimately we are going to put the substitution, that is x by 2 is equal to other variable that is given in the use that variable which is given in the example, that is t. Okay, is equal to t. We get x is equal to 2t. Now regular integration method, that is take derivative on both sides, dx is equal to 2 dt. Now we need to check the indefinite integrals limit. X is a earlier variable, t is our new variable when x limits are 0 and infinity. Put x is equal to 0 in this equation, we get t is equal to 0. Put x is equal to infinity, obviously we also get t is equal to infinity. Limits doesn't change, that's why put this above all terms here, we get 0 to infinite limits, sine square as it is, this becomes t divided by x square, x is 2t here square, and dx becomes 2 dt. This as it is pi by 4. Now this 2 square becomes 4, and this 2 to the 4 gets cancelled, 1 by 2 take outside, and it becomes integration 0 to infinity sine square t upon this t square only dt. Okay, is equal to pi by 4. Now take 2 on that side, we get integration 0 to infinity sine square t upon t square dt becomes this 2 to the 4 pi by 2. Okay, this is the question. Now let us see next example, 20th example. Find Fourier cosine transform of fx is equal to this. Okay, this is also very important example. See, find Fourier, this is a straightforward Fourier cosine transform we have to find. Let FCS is the Fourier cosine transform of the function fx is given by 0 to infinity fx cos sx dx. Okay, okay, now put this fx value. Let I'll suppose for our convenience every time you don't need to write FCS all the time, that's why let I is equal to this integration 0 to infinity fx, put the value of fx even in the example 1 upon 1 plus x square cos sx dx. Okay, now this integration can't be solved by usual method. Okay, you can try about by part rule, because by part rule is depend on what integration u into v is u into integration of v that is suppose suffix u into integration of v. Suffix means integration, dash means derivative, minus u dash v second derivative plus u double dash v third derivative, and so on. This series will end, or by that series we get only definite answer if and only if this derivative becomes 0, because in derivative and integration process we get 0 in derivative process only. Okay, because constants derivative like 4 derivative is 0. Okay, but fourth integration is not 0, right? That's why the series ends, means series gets 0 value in after some terms. It depends on this function only, u function, right, whose derivative after sometimes becomes 0. Like for example, x raised to 4 derivative is 4x cube. 4x cube derivative is 12x square. 12x square derivative is 24x. 24x derivative is x. And last, x derivative is 1 and 1 derivative is 0. This derivative process ends at 0. Okay, integration of x square or any function can't give 0. That's why here, if we consider this as u, because this is arithmetic term and this is trigonometry here, then this integration, this function's derivative is not going to be 0. That's why we can't solve this integration by your usual by part rule or any method. That's why we are going to use the DU-IS rule, which we have already studied in the earlier examples. Okay, what is DU-IS rule? Differentiation under integral sign. We have to take derivative both sides with respect to that variable which is present in this integration, but apart from this variable x, that is yes. That's why take derivative on both sides with respect to s. We get di by ds is equal to derivative goes inside the integration, that is the only DU-IS rule, and it becomes partial derivative. That means simple keeping all the variables apart from s constants while taking the derivative. Now this is a constant regarding this derivative, because derivative we are taking with respect to s. Okay, here s is there, that's why cos derivative is minus sin sx into angle derivative should be multiplied with respect to s, that is x, and this integration with respect to dx as it is. Okay, now we have to solve this little bit. Minus outside because it's a constant, x sin sx upon 1 plus x square dx. Okay, now this integration also we can't solve it by our usual method. That's why what we have to do, we have just small adjustments here. See, here x square is there, that's why we are going to adjust this term in the numerator. Now what is the procedure? First we have to make this x to x square first, that's why multiply and divide by x square, this numerator and divide by denominator. We get x square sin sx upon x into multiply by denominator also into 1 plus x square dx. Okay, now adjust this term in the numerator, 1 plus x square. For that we have to add 1 and subtract 1 in the numerator to this x square only, sin sx as it is. That's why it becomes 1 plus x square minus 1 sin sx upon x into this denominator as it is dx. Okay, now what we are going to do, this we are going to take one term and this other term, and we are going to separate out these denominators. See what we are going to do, di by ds RHLS side is equal to minus as it is 0 to infinity this term divided by this term into sin sx. Okay, minus 1 into sin sx upon this term dx. Okay, you can write dx outside. Okay, now separate out the integration. While separate out the integration, 1 plus x square cancel with this 1 plus x square. It becomes minus sin sx upon x only dx. And plus take the integration, this minus minus becomes plus, 0 to infinity sin sx, this term as it is. Okay, now if you observe this integration is a standard integration which has definite value. What is that? We have already read that, we have already written that note here before this 18th example. Note number 1, that is this everywhere here. Fifth note is there, 0 to infinity sin ax upon x dx is pi by 2. Whatever the value of a here is a constant, it's a here. The answer for this integration is pi by 2. That's why we are going to use that formula or integration. Value of this is pi by 2, minus as it is, minus pi by 2, plus this integration as it is. Call that equation number 2. Already we have given our I as equation number 1. Now it is the only example where we are going to use double Eos rule, because we want to simplify this term. Now again differentiate with respect to s both side. This is double Eos rule. Differentiation of single integration is double integration, minus this is a constant, that's why it becomes 0. Derivative is 0, plus integration 0 to infinity. Now we have to take in derivative of this term with respect to s. S is present in sin sx only, that's why this denominator is constant as it is, and integration of sin is cos sx into derivative of angle should be multiplied with respect to s we are taking is x. Okay, dx as it is. Now this x gets cancelled on next term. We get 0 to infinity cos sx upon 1 plus x square dx. And you observe this integration. This integration is, and our original integration is same. Okay, that's why this is equal to I, our original integration. Therefore d2i by dx square is equal to I. Now we have to solve this integration. Take I on that side, we get this term, and take d square means this is our usual notation where d square capital D, and capital D is a notation for derivative d by ds. D square I minus I is equal to 0. Take I common from the both the term, we get d square minus 1 is equal to into I is equal to 0, and this is LDE, linear differential equation, which we have already studied in the M2 or M1 somewhere. Okay, how to solve it? Just take auxiliary equation. This is called auxiliary equation. Taking d square minus 1 is equal to 0. Now we have to find out the root of this equation. A plus m square minus b square is a plus b into a minus b is equal to 0. Values of d are, one is minus 1 or other is plus 1. Now what is the solution of RHS side is 0, that's why no pi is there. Solution of this is I is equal to CF plus pi, where pi is depend on the RHS side of the equation, which is 0, that's why it is 0 here. Okay, but this is reason. And CF is depend on the roots of the equation. Roots of the equation are simple and different, that's why solution is C1 e raised to 1 into s plus C2 into e raised to minus 1 into s. Okay, this is LDE simple equation. Call this equation number 3. Okay, now we have this is equation number 1 in I, and this is equation number 3 in another I. Now we have to use the s value here to find out constant C1 and C2. Okay, that's why put s is equal to 0 in both equation number 1 and equation number 3. LHS side is same, that's why what we get, I is equal to, if you put s is equal to 0, we get from 1 I is equal to integration 0 to infinity 1 upon 1 plus x square dx, and integration of this is tan inverse x 0 to infinity. Put upper limit tan inverse infinity, we know pi by 2, and tan inverse 0, we know 0. Answer for I is pi by 2. Now put s is equal to 0 in 3 above equation. What we get? I is equal to e raised to 0 is 1, e raised to minus 0 is again 1, c1 into 1 plus c2 into 1, that is c1 plus c2. Okay. Now from these two equation, LHS side is same, that's why RHS side must be same. From these two we get c1 plus c2 is equal to pi by 2. Call that equation number 4. Okay. What is our motto? To find out values of c1 and c2 constant. To find out two constants, we need two equations. From that one equation, what we already get it here. To find out other equation in c1 and c2, we have equation number 2 here, which is derivative of I, and we already get I. That's why we are going to put s is equal to 0 in equation number 3, and for from equation number in equation number this 2, and from this equation number 3 we are going to differentiate this equation to get again second di by ds, and in that also we are going to put s is equal to 0, and equating those two equations we get other equation in c1 and c2. Okay, let us see first. Put s is equal to 0 here, or before that we can differentiate this equation. Okay, differentiate equation 3 with respect to s. What we get? Di by dx is equal to c1 constant as it is, e raised to s derivative is e raised to s, plus c2 as it is, e raised to minus s is minus c2 e raised to minus s. Okay, call that equation number next 5. Now we get 2 di by ds. First is this and second is this one. Now put s is equal to 0 in this equation and this equation. What we get? Now put s is equal to 0 in equation number 2 and 5. We get di by ds is equal to minus pi by 2 from earlier equation here. Because sin 0 is 0, this integration becomes 0. And from this integration, di by ds becomes, put s is equal to 0. We get c1 e raised to s, that is e raised to 0 is 1, minus c2 e raised to 0 is 1, c1 minus c2. Now from this two equation, LHS side is same, that's why RHS side must be same. c1 minus c2 becomes minus pi by 2. Okay, this we get second equation in c1 and c2, and this is our first equation in c1 and c2. Now we have to simultaneously solve the given equations. Solving 4 and 6, this is 6, earlier was 4. For c1 and c2 we get, adding this, just these two equations, we get c1 plus c2 is equal to pi by 2, c1 minus c2 is equal to minus pi by 2. Add this, we get c2 gets cancelled, 2c1 is equal to 0, c1 is equal to 0. Now put this value in any equation, that is 1, we get c1 0, that's why c2 is equal to pi by 2. Okay, now put these values in our answer. What is our answer? Value of I integration, that is this equation number 3. Therefore we get I is equal to c1 from 3, c1 e raised to s plus c2 e raised to minus s, c1 is 0, that's why I value is pi by 2 e raised to minus s. What is our I? Our original question, that is, this is our notation. Original question is FCS, finding the Fourier cosine transform. That's why final answer is FCS is equal to pi by 2 e raised to minus s. Okay, these are some important examples which are lengthy and having different type of way of solving using DOIS rule. Already we have studied DOIS rule single time. In this example we are using it twice.